In the vast realm of scientific understanding, one question persists, often defying the overwhelming evidence to the contrary. Could the Earth be flat? It's a notion that has captured the imaginations of some, leading to a modern-day resurgence of flat Earth beliefs. In this discussion, we'll explore the arguments put forth by flat earthers, scrutinize the evidence, and delve into the fundamental principles of science that confirm our planet's true shape. First, let's address the most fundamental piece of evidence for a spherical Earth, the curvature of the Earth's shadow on the Moon during a lunar eclipse. When the Earth comes directly between the Sun and the Moon, it casts a circular shadow on the lunar surface. This shadow is always round, regardless of where one observes the eclipse from on Earth. It's a phenomenon that can only be explained by a spherical Earth. If the Earth were flat, the shadow would appear as a straight line, which it does not. Another compelling piece of evidence comes from the field of navigation. Mariners have been using the principles of spherical trigonometry to navigate the seas for centuries. GPS systems, which rely on signals from satellites orbiting a spherical Earth, would not function as they do if the Earth were flat. Airplane flight paths, which are based on the great circle routes that are only applicable to a spherical Earth, further confirm our planet's true shape. But what about the perspective of the horizon? Flat earthers often argue that the horizon always appears perfectly level, no matter how high you go. While this may seem true from our vantage point on the ground, it's a limited perspective. As one ascends to higher altitudes, the curvature of the Earth becomes more evident. This is why, from the window of a commercial airliner, you can observe the gentle curve of the horizon. Additionally, the phenomenon of ships disappearing over the horizon's edge is a clear demonstration of the Earth's curvature. As a ship sails away from an observer on the shore, it gradually disappears from view, with the hull vanishing first, followed by the mast. This phenomenon is entirely consistent with the curvature of a spherical Earth. Flat earthers often challenge the idea that gravity is what holds us to the Earth. Instead, they propose that the Earth is constantly accelerating upwards, creating the sensation of gravity. However, this idea is not supported by any scientific evidence. The force of gravity has been thoroughly studied and measured, and it consistently points towards the center of mass, which is at the core of our spherical planet. The phenomenon of time zones is another compelling piece of evidence for a spherical Earth. As the Earth rotates on its axis, different parts of the world experience daylight and darkness at different times. This rotation creates the need for time zones, which would not be necessary if the Earth were flat and the Sun always illuminated the entire surface. Furthermore, the changing constellations observed as one travels from the northern to the southern hemisphere provides additional evidence for the Earth's curvature. Different constellations become visible in the night sky as one moves closer to the poles, which is consistent with a spherical Earth. Flat earthers also question the validity of images of the Earth from space, alleging that they are manipulated or faked. However, these claims have been debunked by experts in photography and image analysis. There is an abundance of satellite imagery and video footage that consistently depict a spherical Earth. The concept of a flat Earth also faces significant challenges when it comes to explaining phenomena such as seasons and the behavior of celestial objects. The tilt of the Earth's axis is responsible for the changing seasons, with different parts of the Earth receiving varying amounts of sunlight throughout the year. This phenomenon is consistent with a spherical Earth, but difficult to explain within a flat Earth model. Additionally, the motion of celestial objects, such as the Sun and stars, across the sky is consistent with the Earth's rotation on its axis. In a flat Earth model, these motions would be difficult to account for. One argument put forth by flat earthers is the idea that large bodies of water, such as oceans, appear perfectly flat with no noticeable curvature. However, the curvature of the Earth is indeed present, but it's not easily perceptible over short distances. To observe the curvature directly, one would need to cover a significant span of distance, such as crossing an ocean or observing distant mountain ranges. The phenomenon of the Coriolis effect, which causes moving objects to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere, is another piece of evidence that aligns with a spherical Earth. This effect can be observed in the rotation of hurricanes, the direction of ocean currents, and even the trajectory of long-range artillery. In conclusion, the idea of a flat Earth is not supported by the overwhelming body of scientific evidence. From the curvature of Earth's shadow on the Moon to the observations of celestial motions and the principles of navigation, the evidence consistently points to a spherical Earth. While it's important to critically examine and question scientific theories, it's equally important to base our understanding on well-established principles and empirical evidence. As we conclude this discussion, I encourage you to continue exploring the wonders of our planet and the universe through the lens of science and critical thinking. If you found this exploration of the flat Earth concept informative, Please consider giving this video a thumbs up, sharing it with others to promote scientific understanding, leaving a comment to share. Thank you for joining us in this exploration of scientific inquiry, and I look forward to sharing more fascinating topics with you in the future.